Page that you can use as kind of your study, this first page here. When we launch an object into the air, we call it a projectile. Projectiles travel in a parabolic trajectory. They travel in a parabola. That's not quite true. That's only true if the Earth is flat. But the distances we're going to be launching them, the Earth is going to be close enough to being flat that we're going to pretend it's flat. It's not. But it's much easier. You could, by the way, you could analyze it with all the parabola stuff you used last year. In other words, if you wanted to find the highest point of a projectile, that's the vertex. You learned how to find the vertex last year by completing the square. But it's much easier to break it into components and use vectors. So we're always going to break a projectile into vertical and horizontal components. Here is a projectile that's been launched at 24 meters per second at an angle of 36 degrees above the horizontal. We're going to describe our directions as above the horizontal, because we're looking at a side view, or below the horizontal if it's going down. Technically, up is not north. North is that way on a map. So anyways, it's at an angle. Everybody, did I say angle? So we would go like this. We would call this Vx. We would call this Vy. Y is my abbrev for vertical, like on a graph. X is my abbrev for horizontal. I would go color, 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 color. Dallas 24, opposite, adjacent, or hypotenuse. What about Vy? What about Vx? Let's find Vx, which trig function has the a and the h. And again, if you're a little shaky, you should have written SOHCAHTOA at the top of your page. Cos. So I'm going to say, all right, cos of 36 equals Vx over 24. And so over here, I'll write in my notes, it's going to be 24 cos 36. And I get 19.4, and I carry some extra sig figs because typically I'm going to be using the components, so I get 19.416. 19.416 meters per second. There will be a question on your test for 1 mark where I just give you something and ask you to find the components. Probably more than once, but definitely I'll give you velocity at an angle. Did I say angle? And I'll ask you to find the horizontal and vertical components. Stephen, which trig function am I going to use to find Vy? It is sine. I'll do that right here. Sine of 36 equals Vy initial over 24. Why did I stick in an initial on the Vy and not on the Vx? Because Vx doesn't change, but Vy does. As soon as it launches, Vy is going to get smaller and smaller and smaller until at the top for a split second it's 0, and then it's going to get bigger but negative, bigger but negative, bigger but negative until it hits the ground again. Vy is going to be 24 sine 36. You might have noticed that you can just backspace and edit on your calculator. I've tried to give you good calculator tricks along the way and teach you how to use these properly. And I get 14.107. Is that correct, folks? Okay, if I make a mistake, please let me know. So one skill, and I kind of hope you're at the stage now, Geo, where that would be free marks. If I said find the components, you would say, oh, okay, I'll do it. I'm going to get perfect. I've done so much of this. Just don't be sloppy. Be cautious. Don't mix up your sine and your cosine or your x's and your y's, and you'll be good. Here's a summary. This is a kind of a nice summary of everything we've done so far. So horizontally, Vx is constant because Ax is 0. Which means that d equals vit plus a half at squared just becomes dx equals vxt, and we call that the range. In fact, last class I suggested you could add that to your blue sheet. dx equals vxt, dx is a synonym for the range. What this means is if you know the time of flight, you can find the range, but also if you know the range, you can find the time of flight. If they give you the range, then the time of flight is just dx over vx. And you'll notice no quadratic, no square root, no nothing. If you're lucky, the question gives you the range. That's the easiest of all of the various projectile pieces of information that they can give you. What about vertically? Well, vertically, Vy is changing, but Ay is constant, negative 9.8 meters per second squared if we're on the Earth. So D equals Vi y initial t plus a half A, and I should have put an Ay right there, t squared. Now, if you're launched horizontally, Vy initial is 0, and so this equation gets modified. But if you're launched at an angle, Vi is not 0, and we're stuck with this. Some things to note: at the very top of its arc, Vy is going to be 0. Does this mean that the overall velocity is 0? No, it means velocity at the top is just Vx, because that's the only component that's left. That can be handy to have in your back pocket. If the question says, find the velocity at the very top, you're done if you've already found Vx. You don't need to do anything. You don't need to find t. You don't know anything. You know the V at the top. It's Vx. Also, if you start on the ground and end on the ground, Vy initial is negative Vy final. What goes up must come down. That only works if you start on the ground and end on the ground, because your path will be symmetrical. Doesn't work from a cliff. Finally, if you're starting from a vertical height, a cliff, and you're ending up below from where you started, your dy will be negative when you list it in your t table, because it's a displacement. That's something else you want to have up in your brain and pay attention to. Having said all that, so that's a nice summary of everything we've done so far. Oh, Mr. Dueck, you said that projectiles travel in a parabola. Yes, they do. But I've seen some that seem to wobble. That's a good point. Put your pencils down, look up. I should be very, very careful. What travels in a parabola is a projectile center of mass, but not all projectiles have their center of mass at the center of the object. So here's tossing some objects under bright white lights. This does not have its center of mass at the center of the object. You're going to see if you toss a badminton racket or a tennis racket, it'll look like it's wobbling. Let me back up. You can see it had kind of a wobble to it. This will also look like it's wobbling because its center of mass is not the center of the object. And that one definitely had a wobble. Oh, let me pause the video for a second for a latecomer. Pause. Now, same objects under a black light with the center of mass painted orange. No wobble. Because the center of mass will travel in a parabola. Again, no wobble, even though they're spinning. That disc, so there's the center of the disc. You can barely see. It's a little tough. We can dim the lights a little bit. The center of the disc is not the center of mass of the disc. So the center of the disc is going to wobble because that's not traveling in a parabola. Wobble, 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 wobble. But now, if we turn it around, there's the center of mass, parabola. So I should point that out, okay? It is true, objects might appear to wobble, but their center of mass will always travel in a parabola. Here's the point of today's lesson. Projectiles from cliffs at an angle. There are 3 approaches to handle this. One strategy would be to find the time to the very top, because you know Vy final is 0. Then start at the top, let your Vy initial be 0, figure out how long it would take to fall down, and then add them together. That I give a meh. Another strategy is to do the whole thing all at once. Yes, you know me enough to know I won't take 3 steps or 2 steps if I can do it in 1 step. That middle strategy is going to require the quadratic formula. Strategy 3 I don't recommend, but it works. Find the time to top by letting Vy final be 0. Double it to get the time back here. Let your Vy initial be negative Vy final. Let your Vy right here be negative Vy initial. Find the time to fall and add all three of these together. Not wild about it, but it works. Geo, I'd rather just do it all at once. So on your test, which is, what did I say, October 9th? So 2 weeks from now? No. Yeah, I guess 2 weeks from now. I said you're going to have 4 written questions. One is going to be airplane in a crosswind or a boat crossing a river. One is going to be a projectile launched horizontally from a cliff. One is going to be a projectile launched from the ground at an angle. Did I say angle components? And the toughest, it's going to be projectile launched from a cliff at an angle. Like, I like example 1, I like example 1, I like example 1. Afan, what's example 1 asking me to find? What's B asking me to find? I might just ask you part B and expect you to clue in that you got to find part A. Is this a projectile? Say yes. So we are going to use a t-table. Over here, I'm going to draw my t-table right now. X, Y. Do you remember, Afan, what are the 2 no-brainers that I can write without thinking about it? I nicknamed them our physics no-brainers. They're the accelerations. AX equals 0. AY equals negative 9.8. And again, this is in keeping with my big philosophy. I like writing something down mindlessly. I feel better. I've written something down. What else? It looks like this is being launched at 50 meters per second at a 30-degree angle above the horizontal. Did I say angle, everybody? Next thing I would do is I would find the components. I'm going to zoom in a little bit. I would go, okay, D. I almost always do the X component first for a projectile. D, Vy initial. Oh, how come I put an initial on the Y but not on the X? Any chance I get, Maliko, I want to remind myself the X doesn't change, which is why there's no initial or final. It's always the same, but the Y one is changing. Maliko, this 50 right here, opposite, adjacent, or hypotenuse. Vx. Oh, color. Good. Vy initial. Good. Let's find Vx, A, and H. Which trig function? If you have not written the word SOHCAHTOA at the top of your page, you need to. Which trig function is the A and the H, folks? Okay, it's cos. It's going to be 30 equals Vx over 50. Final step, Maliko, how would I get the Vx by itself? How would I move the 50 over? Yeah, let's just do that on our calculator. I'm not going to even write out that step. I think you're good enough that I can trust that once you have the fraction, you can rewrite it with formula manipulation. So it's going to be 50 cos 30, and I get 43.301. Vx equals 43.301. Which trig function is Vy going to be, Luke? O and H. It's a sin when you call it sin. We're going to call it sine. So it's going to be the sine of 30 equals Vy initial over 50. No problem, Luck. 50 sine 30. Or I could have just backspaced and edit. This one works out evenly. I happen to know the sine of 30 is 0.5. It's just one of the random things I've memorized. So I know it's going to be a nice even 25. Cole, how many things do I have in the X column? How many things in the Y column? There must be, oh, they told me one more thing in the diagram. That's 60. What is it? What are the units next to it? So it's a displacement, vertical or horizontal. What am I going to write? dy equals, no. So you made, unfortunately, you made a mistake that last year, if you made that mistake, your calculator would have given you an error. This year, your calculator won't give you an error. What's his mistake? Why is dy not 60? Has to be negative. It's a displacement. You're ending up below. And I'm kind of glad you did that for everybody to make note of that, but let's not do that one again. Last year, because we didn't have any sideways motion, typically if you didn't make the displacement negative, you would have gotten an error, and that would have clued you in, oh, I've done something wonky. This year, because this is going to be a full quadratic formula, you'll still get two good roots. So just be cautious. Which column do I have three things in, Cole? Afan, back to you. I'm looking for an equation that has an A, a VI, a D, and a T in it. There is one. Yeah. I'm going to do part A here. Now, I've got organized in my T table, but there's not enough room in my T table to show good work. And this, I'm not going to cut very many corners on. So the first thing I'm going to write is dy equals Vy initial T plus a half Ay T squared. And unfortunately, nothing is a zero here. This is a full quadratic. So all I can do is plug in my values. I'm going to get negative 60 equals 25t minus, I might go 0.5 times negative 9.8 and get the 4.9 t squared, because that's what it's always going to be because of gravity in my quadratic formula. How can I tell this is a quadratic? It's got a squared. And unfortunately, there's also a t, which means I can't get the t squared or the t by itself. I have to use the quadratic formula. Who remember what was step 0 for the quadratic formula, Afan? Yeah, and although it would be quicker to plus the 60 over, I've just learned I make more dumb mistakes when the quadratic term is negative. So, Nolan, I'm going to plus this to that side minus this to that side, and I'm going to get positive 4.9t squared. Take away 25t, and then the minus 60 drops down like a domino, equals 0. Where 4.9 is A, B is negative 25, C is negative 60. Now, those of you that have the built-in solver will be done in about 10 seconds. The rest of us, we've got to do this the long way. T equals negative B, that's going to be positive 60, plus or minus the square, no, negative B, Mr. Dueck, not, geez, it's going to be positive 25, Mr. Dueck. Plus or minus the square root of b squared, negative 25 squared, minus 4 times 4.9 times negative 60, all over 9.8, 2a. And I'm going to carry my time value probably also to 5 sig figs because I'm going to use it. How am I going to type this in? Bracket 25 plus square root bracket 25 squared. I know I wrote negative 25 squared, but I'm lazy but organized. I know negative 25 all squared is going to be the same as positive 25 squared, so I'll save myself some typing in brackets. Minus 4 times A times C, close off the square root, close off the top, divided by 9.8. Those of you with the solver, is one of the roots 6.8814? And then I should be able to backspace and edit. Negative 1.7794. Which one of these am I going to ignore? Okay. Mr. Dueck, yes, Clara. What is that negative root, like what does it mean in physics? For what it's worth, it says this. If you went backwards 1.7794 seconds, that's when you would hit the ground. If you could somehow go through the earth, but unfortunately the cliff is in the way. So it kind of does mean something. It is kind of neat. It's actually telling you how far back in time you'd have to go if you had launched from the ground to end up at this location. But for what it's worth, that's just nerd trivia. I'm never going to ask you that. They wanted me to find the flight time, so the final step, Afan, I'll report my answer to my usual 3 sig figs. I'll put the units. I'll even draw a box around it. Ta-da. So this is from a cliff at an angle. If you're finding time, you're going to spend most of your time finding time. You're going to solve a quadratic. Now, if you're lucky, if they had given you, instead of the height, if they had given you the range, Then it's not a quadratic. Then you can get the t by itself in 2 lines and you're done. And there will be a couple of questions in the homework router where I give you the range instead of the height. But typically, and I'm going to tell you right now on the test, I'm going to give you the height. Router, what does B want me to find? Oh, hang on, I got to pause for a second. Router, what's B want me to find? Okay. You'll notice I left you way less room for work. Here I left you a whole third, well, 2/3 of a page. Find the range. The range, that's dx equals vxt. What happened to the plus a half at squared from your t table? What's ax? Yep. Okay. And what did we just find in part A? That's why we can go straight to here. I've scrolled down. What was vx? It was, I can't even remember. 43.301 times answer button of your positive root. So I'm going to cheat. I'm going to go back and I'm going to say I don't want the negative root on my calculator. I want the positive root. And now I can go 43.301 times my answer button or times 6.8814. And I got a range of 297.97. You know what? 298 meters. That's a question I can ask you if I give you launched from a cliff at an angle. Or I could ask you part C. Okay, what does part C want me to find? First of all, time to reach the top. Do you think we're going to handle this vertically or horizontally? The word top, what would that suggest? I think vertically, okay? So I'm not going to do a full T table here. I am going to say, okay, it looks like they want me to find T top equals question mark. Can I still use AY negative 9.8? Yes. And I think my initial vertical velocity is still 25. I can't use the 298. That's horizontal, so don't you dare. Oh, I know something vertically at the top. What's 0? VF is not 0. I got to be fussy. Vy final is 0. VF is Vx right at that moment. So I'm going to try and drill that out of you. Vy final is 0. And so now, Mikhail, I'm looking for an equation that's got a T and A, a Vi, and a Vf. There is one. Get the T by itself, please. It's going to be T equals Vy final minus V, right? Final minus initial over A. So that's not too bad. In fact, you didn't even need to do a quadratic for this one. I might ask you to find the range for 5 marks, and this might be a little 2-mark bonus or part 2 or something like that. It's going to be 0 minus 25 all over negative 9.8. I mean, I know it's going to be less than 6 point whatever, because that's when it hits the ground. 2.55 seconds, 2.5510. I'll just write 2.55 seconds, because I don't know if I'm going to be using this or not. Probably the toughest question in terms of work and having to really pay attention would be part D. I would consider this a solid A or A plus. A. I'll show you an A plus level question in the homework. But this would be a solid A level question. It wants you to find the impact velocity, and it's not 0. Again, if the impact velocity was 0, you could do a belly flop off of your lab table and it wouldn't hurt when you hit the ground. It's going to hit the ground hard. I don't quite know what the impact velocity is going to look like, but I can sketch it. Look up, please. Don't write this down. I think it's going to hit the ground like that. Maybe steeper, maybe shallower. I don't know, but I can tell you when it hits the ground, it's going to be traveling down at an angle. At an angle. At an angle, everybody. So here's what I'm going to do. If you want me to find the impact velocity, I'm just going to kind of sketch a long line like that. Might be steeper, might be shallower, but this right here is V impact. And I put the V impact underneath it because I am going to break this into components. And which component do I always draw first? Vx. So I'm going to break this into Vx, and this is going to be Vy final, not initial. Hey, I know Vx because it never changes. From your t-table, what's Vx? It's going to be that right when it hits the ground. It's going to be moving sideways at that velocity. So I can use that. It's going to be 30, what was it, Mr. Dueck? 43.301. 43.301. Do I know how fast it's traveling vertically right when it hits the ground? No. So I'm going to walk over here and I'm going to do a mini, not full t-table, just the vertical section. I'm going to say, okay, I know AY equals negative 9.8. I know Vy initial was 25. I know dy was negative what? Oh, and I know the time when of impact, that was the total time, that was 6.8814. Okay. From that, I can find time. Sorry. From that, I can find Vy final. I can find what's going to go there. How? I'm looking for an equation that's got a Vy final and any of those in it. Yeah, Mikhail. Which one? That's what I would choose because it's the easiest, and my goodness, the Vy final is by itself already. You could also use Vf squared equals Vi squared plus 2AD. I wouldn't. You could also use D equals bracket Vi plus Vf times T over. I wouldn't. Those would all work. I would use that one, the Vy is by itself. So I wouldn't actually even use this. Now, the risk I'm taking is if I got time wrong, I'm getting this wrong. But we're at the stage now, Gio, where okay, if use an answer to find an answer, just make sure your first answer is right. So I can say Vy final equals Vy initial plus Ayt. It's going to be 25 plus negative 9.8 times 6.8814. Before we crunch the numbers, Mikhail, look at the picture. What direction is Vy final pointing in my diagram? You looking? Am I expecting a positive or a negative answer here? I better get a negative answer or I've messed up. 25 plus negative 9.8 times 6.8814. 14, Mr. Dueck. How fast are we traveling right when we hit the ground in the vertical direction? Negative 42.438. Is that what I said, Mr. Dueck? Yeah. So I can put here 42.438. Mr. Dueck, what happened to the negative? It's in the arrow pointing down. I've got it actually in my picture, right? Down. So I don't need to actually call the side negative. It's there. Now I've done most of the hard work. How could I find the magnitude of the impact velocity? Starts with letter P. Pythagoras. And then where am I going to put theta? Top left or bottom right? Where is the impact velocity coming from? So theta is going to go here, color, color, color. To find the magnitude of the impact velocity, it's going to be V impact squared equals 43.301 squared plus 42.438 squared. What's the magnitude of the impact velocity? It's going to be 43.301 squared plus, haha, answer button squared, since I have that sitting there, square root. And I get 60.6. meters per second at color. Nolan, Vy final, opposite, adjacent, or hypotenuse based on this. Good. Vx. And I don't know why I didn't put an equal sign there. Which trig function has the O and the A in it? Yeah, it's going to be shift tan. Tan mystery angle equals opposite 43, no, opposite, Mr. Dueck, 42.438 over adjacent 43.301. I can make a prediction. These two sides are almost the same length. It's going to be really close to a 45-degree angle because this is almost an isosceles triangle. It's not quite, but it's really close. So that's my guess. Let's find out. It's probably going to be 44 point something or 45 point something. Shift tan 42.438 over 43.301. What'd you get? Yeah, 44.4 degrees. North to south, east. Well, you know what? If you called this south of east, I wouldn't mark it wrong, but I'd give you a bit of a stink eye because down is not south and up is not north. We're looking at this from the side. So we would call this below the horizontal. That's if it's heading down. If it was on the way up still, that would be above the horizontal. That's almost everything I can ask you if I have you launch from a cliff at an angle. Did I say angle? Components. And there's no way I would ask you all of these in a single question because you can see each one of these took a fair bit of time. I'm not going to have you spend that much time on a question, but I've got multiple versions of my tests. They all have a cliff at an angle. In all of them, you will be finding the time. Hey, some of them will ask you to find the range. Somebody ask you to find whatever. Example 2, I like example 2. It says find the range. Okay, let's analyze this. Is this a projectile, Katie? T-table. X, Y. What can I write as my physics no-brainers? AX equals 0. AY equals negative 9.8. Joey, is this being launched at an angle? Did you say angle? There we go. So I'm going to do that right now. Now, this looks a little small. I might be tempted to go, you know what? I'm going to draw a bigger triangle right here just so I can work with it. Here's Vx. Here's Vy initial. How come I put an initial on the Vy? Because that's the one that's changing, because that's the one that has an acceleration that isn't 0. Color. That's 20 degrees. Sorry, not 20 degrees. Sorry. Wow, I put that 20 in the wrong place. That was dumb. 20 degrees goes there. This is 35. Dom, that 35, opposite, adjacent, or hypotenuse? 35, opposite, adjacent, or hypotenuse? What about Vy? What about Vx? Hold on a second here. Dom, which trig function is Vy going to be? O and H. Luke, which trig function? Sine? Yes? Which trig function was Vy right here? Which trig function was Vy right here? Which trig function was Vy right here? Sine, yes? Somebody say cosine? Huh. If I give you the angle from the side in that position, which I will, Vy will always be sine. That doesn't work for a boat crossing a river or an airplane, but for a projectile, are you ready for your stupid hook? Vy is sine. Can you all guess what Vx is? Of course you can. If you're looking for a cheap hack. Okay. You can also just do the trig and derive it, which takes an extra 10 seconds. It's not that big a time saver. But for a projectile, because I will always give you the angle with the horizontal, Vy will be sine, Vx will be cos. Just saying. Which means if I'm feeling particularly bold, I can just say right away, hey, I know Vy is going to be 35 sine 20. I can type that into my calculator right now. 35 sine 20. And I can say Vy initial is going to be 11.971. Vx is going to be cosine. I can just backspace and edit. 32.889. Okay. What else did they give me in this picture that I can maybe add to either a horizontal or a vertical column? By the way, you'll notice we never use the slanty again. Once we go components, it never shows up anywhere. Same with the previous question. There is a temptation to think, isn't that the initial velocity? It's neither horizontal nor vertical. It can't go in any one of those columns. It can't go in any of our equations because it's neither horizontal nor vertical. We're not going to use it. What else do I know, Marcus? Thank you. dy is negative 20. Crystal, what does this question want me to find? What am I really going to spend most of my time finding? Yeah. Which column can I find time in? Because I gave you three things. Yeah, I'm going to make a little note here, t equals question mark. I'm looking for an equation that has a d, a v, an a, and a t in it. There is. Yeah, it's going to be the full quadratic. It's going to be dy equals vy initial t plus a half ay t squared. It's going to be negative 20 equals 11.971 t minus 4.9 t squared. I did half of negative 9.8 in my head. Crystal, what kind of an equation is this? Starts with letter Q. How do you know? It's got a squared. What's step 0? Make it equal to 0. I'm going to make it equal to 0 by plussing that over and minusing that over. And I'm going to get 0 equals 4.9 t squared minus 11.971 t. The minus 20 just drops down like a domino. Maliko, you and I are going to do this together, okay? Have you written that down already? Almost. So far, so good. What's A? That, put a box around it. Write that yourself. Do that. What's B? Put a box around this and put a B there. What's C? Put a box around that and put a C there. It takes 2 seconds and that cuts rid of a lot of sloppy mistakes. Okay, you got that? Let's write out the quadratic formula, which is on the back of your formula sheet if you've forgotten it. It's T equals negative B. It's on the back of your formula sheet, so I don't think you're on the right. Positive 11.971 plus or minus the square root. Yeah, and I'm not going to type the negative on my calculator, but I'll make a note that it was negative all squared minus 4 times A times C all over 2A, which is positive 9.8. And again, Cole, this is where I was saying to you, if we had missed that negative displacement, we would still get two different roots from the quadratic formula. You wouldn't have an error show up that told you had made a sloppy mistake this time. Maliko, you ready to start typing? Yeah? No, you're still writing. Okay. Those of you with the built-in solvers are smugly just sitting and going, oh, these poor schmucks. I know. Okay, clear your calculator, open up a bracket, because you don't have the fraction button, do you? You have the two-level fraction button? Do you have the fancy fraction button? Show me your calculator, kiddo. Show me the front. Oh, okay, so you can press fraction button. I have to open up a bracket. I need you here, kiddo. Hey, I need you here. You can press the fraction button. I need to open up a bracket. 11.7, there's a 9. Wow, the 1 didn't show up for me. 11.971, and then plus sign, square root. I have to open up a bracket. Yours probably does a little indent, and it's going to be 11.971 squared. Take away 4 times 4.9 times button negative 20. I have to close off the square root. You probably don't. I have to close off the top. You can probably just go down arrow. Divided by 9.8. Is the first root 3.5824? I need some nods from the solvers. Yes? Did you get the same thing? Did you get that? Yep. Don't clear your calculator, please. So you get 3.5824 seconds, and then you also get a negative root. I'll just double check to make sure by backspacing and editing. Negative 1.139. I don't care how many sig figs I write because I'm not going to use it. And then because I want this time back in my answer button, I often just quickly bring the positive back. So I've got that positive 3.5824 stored because I'm lazy but organized. Mr. Dueck, will you ever get two positive roots? Yeah, it's possible. Look up. If you launched from a cliff at an angle like that, your projectile is going to look like that. If for some reason you were finding the time at that height right there, you'd get two roots because you're at that height twice. Okay. I don't know if I asked you a question like that in the homework. I can't remember, but it is possible to get two positive roots because there are some times when you're at the same displacement at two different time periods. And that would be anywhere above this section. But as soon as you're below the cliff, you'll get a positive and a negative because you're only at that particular height once. Just saying. Hey, we're not done. This wasn't even what the question asked. What did the question ask us to find? Oh, what did you say, Luke? dx equals question mark. Yeah, dx equals vxt. I've done the hard work. Now I can just drop the vx down like a domino, 32.889 times, and I'm going to use my answer button, but times 3.5824, and I'm good. And I get 117.8. I'll call it 118 meters. This would be a pretty good 7-mark written question, because you can see you have to do a fair bit. If I was marking this, I would give you 1 mark if you found Vy. I would give you 1 mark if you found Vx. I would give you a half mark for writing Ax equals 0. I would give you a half mark for writing Ay equals negative 9.8. You've already got 3 out of 7 without actually doing much of the physics. Then I would probably give you 1 mark for finding time, maybe 2 marks for finding time. And then I would give you probably 1 mark if I saw that equation, and 1 mark for the answer. There's a lot of work that's going on here. Okay? Okay. I think what I'm going to do is I'm going to pause here. But here are some questions from the homework that you can start. Now, honestly, technically, I'm done the unit. All I'm going to be doing now is showing you weird loopholes, weird examples. Technically, you can do every question in the ultimate, guys, you can do every question in the ultimate review. You can do every question from the homework. But for now, I'm going to say from the homework, you can try number 1 is good. Skip 2, you can try number 3. Skip 4. Skip 5. You can try number 6. I haven't done one like number 6 yet. Number 6, they're giving you the range, which makes it way easier. No need for a quadratic formula. Make your t-table, and you realize I can find time horizontally. Way easier. See if you can try that. So you can try, certainly in the remaining few minutes, those questions. And I also know a lot of you are still working on lesson 6. So we'll pause here.